Yeah, so my name's Preston. I'm a full stack engineer over at jam.dev. And today I'd love to talk to you guys about our experience with GraphQL and backwards compatibility. Um, I basically think that there's a lot of ways that you can sort of like hurt yourself with GraphQL. We've certainly experienced that, and we want to share some advice to sort of manage some of that. Um, let's see. Oop. So yeah, what's the need for backwards compatibility? Uh, Basically, like the way I look at backwards compatibility is if you have two systems that need to talk to each other, you want to make sure that they're always compatible, like they're always able to cooperate. Those systems might evolve independently. For the context of GraphQL, typically this is going to be the GraphQL client and the GraphQL server. And as you make those changes in the schema or in the client, um, you really don't want to degrade that user experience. You don't want to cause incidents. So it's really important. Um, and I'd love to share a brief experience over at Jam. So basically, not to like spend too much time on like what Jam is, but Jam is a set of bug reporting tools. Our main platform is through a Chrome extension. So if you install the Jam extension, you can basically capture screenshots, you can capture uh, screen recordings, and you can generate these bug reports. And all this is uh, handled through GraphQL. So we will collect data like the screenshot, um, things like network logs, console logs, and send that to our GraphQL backend. What's kind of interesting about our setup is one of the clients, which is the extension, is a browser extension. And deploying this is actually something that we don't have complete control over in terms of when this gets released out into the wild. We have to do this sort of submission flow. Uh, so basically, we build our extension, we submit it, and it actually takes about 1 to 2 business days for someone on Chrome's end to review it, accept it, and publish it on their store. So what does that really mean? Um, it means that whenever there's a breaking change, it can be pretty painful because we can't immediately roll back those broken clients. So we always have to make sure that our service is backwards compatible. And what better way to like start a talk by like sharing an embarrassing story? So this is an abbreviated timeline from one of our incidents. This is a couple years back, but the basic gist of it was we deployed a new version of our application, and there was some typing that was removed, and we didn't realize the ramifications of that. Um, I think altogether, like the time to resolution was only maybe like 20 to 30 minutes. Like we identified it and rolled back the server code so that old clients would work again. But 30 minutes is pretty dramatic. Like we're very much early stage, but we can't really tolerate that kind of disruption. So for us, any sort of incompatible code is really, really pronounced. It's really painful for us. But to kind of extrapolate this, this affects everyone. Anytime you're making changes to your server code or your client code, you always have to make sure that they're able to cooperate, or else, you'll see these breaking changes. Um, so yeah, I'd love to talk about like some strategies for handling this and mitigating some of that. Um, the first approach is pretty basic. It's just applying versioning. So you can version your uh, GraphQL objects. If you have things like like Git user query, you could version that. You could give it a different name so that older clients can always reference the uh, set of like APIs they need. Another strategy for this is you could parameterize by that version. So you could use another argument or signal with like an HTTP header. But interestingly, the GraphQL team doesn't really recommend this. The more idiomatic way to handle backwards compatibility is actually to make your API versionless. So that's very interesting. So this is the approach that we ended up taking. And the way I like to kind of frame this is like from the server's perspective. Um, to some degree, you're it's with a high degree of probability, like you might have clients that have outdated code. They could be holding on to, like their browser could be holding on to cached versions of outdated client code. Or let's say you have like a real-time application. They might have tabs open for like several days, and whatever client code that they have loaded might be out of date with like a newer release. So it's really important to make sure that those older clients are always able to work. So one of the guidelines is you should avoid removing types. You know, if you have some property or some field under an object, if you remove that, clients that reference that, you know, that'll break their experience. Renaming a type, same thing. It's the same story. If older clients are referencing that name, that experience is suddenly broken. Avoid changing types. Super basic. If you have a type that resolves to a Boolean and it's somehow like you decide to change it to like a number, that sort of expectation can really break down. So really simple, but these are breaking changes, and you want to avoid these for your APIs. Um, the preferred thing to do here is to just add new types. So if you have to add a new property, it's better to add a new one rather than to remove or rename an existing one. Same with queries. If you have a query that you want to refactor, it's better to just add a completely new query rather than change all the semantics of an older query, because older clients will reference that. There's a deprecated directive that you should use if you're handling the server code. But this sort of has caveats. It's loosely enforced. It's not something that will prevent clients from using it, but it's a good idea to mark things that are going to be deprecated and removed, because you know, clients that do introspection on your GraphQL API will see that flagged and, you know, think twice before using a deprecated endpoint. And this is kind of like a follow-up. It's really important to communicate and stage these breaking changes. You don't want to remove a type all in one go. You should ideally mark it deprecated, start removing it from clients. And after a period of time when you know that that client is no longer consuming that, then it's safe to change it on the server end. But there's a lot of mindfulness that needs to be handled for this. One downside that's kind of obvious is detritus kind of builds up. If you want to delete old code, it's kind of hard to do, and sometimes it just builds up. And for us, we still have to this day some objects and properties and queries, mutations that are old and deprecated, but we haven't gotten around to deleting. These things sort of happen, but I think the trade-off is worth it. it's totally worth having the application just work when expected rather than having some things kind of lingering. Um, Another strategy is thinking about how clients can use the introspection API to understand what available APIs there are. We didn't explore this, but you could totally use some kind of library to consume what the GraphQL schema looks like and validate that uh, that the requests that you make are available. And if they're not, you can handle some kind of graceful sort of like error handling. Uh, what we realized out of all this was testing is really, really hard. Um, when if you kind of like distill the problem into having a server that can support many versions of different like clients and front end code, um, you're sort of like taking all of your testing and multiplying it because you have all these different permutations and setups that you want to test. We actually explored this a little bit. What we did was we tried to take our mono repo and we tried to create like a submodule of that repo at an earlier commit and tried to test these interactions from the latest version versus like the previous tagged version. But I think we decided it was way too much work and didn't feel practical. So what we do now is we just sort of like adopt these conventions, and over time, all these sort of like backwards compatibility issues started to kind of go away. But as we like handled all these conventions, I kind of like thought to myself, well, I don't think that's enough, right? These are just conventions, and they're kind of hard to remember. The GraphQL API for our product is kind of like a small piece of the engineering, and remembering these conventions are I kind of empathize if somebody forgets it in a pull request, you know? Like it's easy in the moment, like, oh, you should never like just rename a property that could break things. But if you're onboarding new engineers, they might not realize that. In the GraphQL best practices page, it's kind of a footnote. Like there's not a whole lot of coverage on the ramifications of uh, these breaking changes. And so I spent a little bit of time to think about like how can we automate things to prevent this from happening? And I found a really cool tool, GraphQL Inspector. So as part of our CI, we run this tool to basically warn us if there are any breaking changes. So it'll sort of categorize them if they're safe, dangerous, or breaking. And if it's breaking, we can, block the build and avoid that kind of thing from happening. This is the repo. Uh, if you don't use GitHub Actions, you can also use their command line interface, which is really, really cool. The main command is inspector diff, and you give it two targets. So one is the remote and one is the local. The thing that you can provide uh, is either a URL endpoint, a a file from your local like file system, or you can provide like a repo slug here. So they just reference a GitHub repo. And the way that we set it up is in our staging builds, we compare our local schema to the staging GraphQL service so that we know that any upcoming changes that might introduce a breaking change we'll flag that right away. And we do the same with our production branch. So this is really cool. I highly recommend using this. And that's it.